Hi, this is Christopher Boucher, and I'm going to review how to do a basic exponential probability or exponential distribution type of example, and we'll get started. So, the known lifetime of a certain type of battery is 20 hours, and the life expectancy follows the exponential probability distribution. What is the probability the battery will last? And then there's three different kind of sub parts of this question where we actually do the math. So a lot of people, what they'll do is they'll take this value here. If this is the average life expectancy of the battery, which is 20 hours, they'll break it down into per hour units and then multiply it by the t, which is the first part, which says more than how many, what's the probability that the battery will last more than 20 hours. So you would go and break down the lambda, and you'd say that it is in a per hour unit, which is, what is that? It's like 0.05, I believe. They break it down and then multiply it by 20, and your answer is going to be 1. And that's just the part that's in the exponential distribution part. I go and I do this. I use the t over lambda, and I'll explain it a little bit more as I go. So the formula for this problem is this. T over lambda, and that's the formula that we're going to use. Okay, so for filling in the numbers, we have e. That is the natural logarithm log is what they say, and it's equivalent to 2.718, and then it goes on forever, but that's approximately what it is equal to. In your calculator, most calculators have that already built in, and it goes out a lot of digits, so it's accurate. So I recommend using the built-in e whenever you can. So let's put in the numbers here. We have e negative, and then our t is 20 hours, because it says 20 hours. And then we're going to put in for our lambda 20 hours, and we end up with e minus, and then if we divide that, that's 1. And our answer is 0.3678. And this question says, let's draw this out a little bit. It goes on kind of forever. This one says more than 20 hours. So we're looking for something that's kind of like that. And we could do 20 more than or equal to. And that would be where this probability sits right in here, is that probability value. Okay, so for the next part, we're looking at less than 10 hours. So for less than 10 hours, our equation is going to be this one. Let me start over. It's going to be 1 minus e negative t over lambda. Okay. And so it's very similar to the last one, except when we're all done with the calculation, we subtract it from 1. And that's this other side that we're working on. So what we do is we do this. 1 minus e. We'll put in the number. Our t is 10, and our lambda is 20 still. And that gives us 1 over... This ends up being 0.5, and I'm going to jump down just to the value. The value is, when you calculate this part of it, 6065. And that gives us 0.3935. Okay, so let's draw that out. So it's like this. Okay, and so that is, let's see, less than 10 hours. So we'd say 10 is less than 10 hours, okay. Okay, so let's take a look at the in-between one. The in-between one is a little bit more tricky. So let's see, in-between. So there's a couple ways that you can do the in-between calculation. And one of the ways, I think this is the simplest way to do it, but you can do it some other ways with subtracting some kind of inverse of what I'm going to be doing right here. But the way I'm going to show you is easiest. It seems a little not intuitive, but this is the way you do it. Okay, so for the between 10 to 15, what you do is you just do this. You do E negative, and then you do T, and I'm going to put a little low for the lower limit, and then over lambda subtract E negative T, and then put a U, little u representing the upper limit, and then put lambda. Okay. So what you end up with the calculation, scoot up a little bit, is we go and let's put in what some of these numbers are. So this one is 10 over 20, and then we subtract, and then this one is 15 over 20, and then let's see, I'm just going to write out the actual numbers when we have the calculation here. So it's 0.6065, and then we subtract 0.4723, and we get 0.1341, and that is the area between. Okay. So in summary, I admit the way I do this is a little different, and I believe it's actually easier when we move on when the units are different from each other, meaning this says 20 hours, and this question, let's say it said a certain amount of minutes. Now, with 20 hours and going all the way back to minutes, say 45 minutes, the probability gets really small, and I understand that. But if it said 2 hours, and then you were trying to solve for something that was that had the statement of 45 minutes, it could be a possible calculation that you do. And the way that we do that, I believe, and I'll show you in the next video, I believe it's a little easier than the way that the textbooks teach you. The other thing, which I'll put a link to when I'm all done, is if you do it this way, you can use a table, and it shows you the calculations. And I'm going to talk about this table a little bit more in my next video. But what you can do is you lay out your conversion factor right next to the t, and it intuitively, when you look at it and you break it down in this whole table, you can understand how the different units are related. And the actual unit conversion is in the equation instead of converting it, say, first, and then you're wondering where a certain term came from. Okay, that's all for now, and then keep an eye out for the second video on exponential probability distributions. Thank you.